Here in session 82, we're going to be addressing square roots of quotients. And if you remember, quotient is a division problem. Quotient is an answer to a division problem. And remember, division in algebra is oftentimes written as a fraction, with the top number, the numerator, being divided by the bottom number, or your denominator. So here's our first radical expression here. We have the square root of x over y. And just as we did in the multiplication, you can break each of those parts, each of those portions of that expression apart and take the radical of each one. Same thing is true with division. So the square root of x over y is the same thing as the square root of x, which is your numerator, over the square root of y, which is your denominator. And if we were wanting to use our exponents, we could. The square root of x over y is the same thing as x to the 1/2 over y to the 1/2. Each of those three are just different ways of writing the same thing. However, this second method, where we write the radical sign in both the numerator and the denominator to start with, is oftentimes how you will see it when you are given problems to work through. A couple more quick examples before we move on. Let's just plug in some numbers. If I were to say x is 100 and y is 20, x is 100, so that's going to go in our numerator, and y is 20, that would go in our denominator. That would be the same thing as the square root of 100 over the square root of 20. And we could then work this problem through to a solution. But the main thing I want you to see here is just how to set it up. What if I told you that x is 17 and y is 23? Well, we could go x is 17, y is 23. That would be the same thing as the square root of your numerator, which is 17, over the square root of your denominator, which is 23. So quickly then, that's how you set it up, and that's how you can then break it apart into its parts, taking the radical of your numerator separate from the radical of your denominator. Now let's take a look at a couple problems and work them through to solution. The square root of 2 over 3. Now in algebra, it's oftentimes understood and expected that the most common form of writing a fraction that has a radical sign is to not have that radical sign in the denominator itself. So when you are asked to simplify monomials, etc., that have square roots in them or have root symbols in them, most of the time you will be expected to write that in its simplest form, and its simplest form will not have a radical sign in the denominator. With that in mind, let's go ahead and start. We're going to break this apart. The square root of 2 over 3 is the same thing as the square root of 2 over the square root of 3. But remember, we do not want a radical sign in our denominator. So there is a strategy, there is a method whereby you can get rid of this without changing the value of this expression at all. Remember, in algebra, whatever you do to one side of the equation, you have to do to the other. Or if you're simply left with a fraction, as what we are here, whatever you do to the top, you have to do to the bottom, as far as multiplying or dividing. How can we convert this bottom, this radical 3 that's in our denominator, into a square? And the reason why we want to change it into a square is if we can change this into a square and then we take the square root of it, we're going to be left with an integer as our denominator, and that's what we're after. So the simplest thing to do is to just take whatever number you have in the denominator that's within your radical sign and multiply both the top and bottom by that same number. So what we're going to do is we're going to multiply the top by radical 3, and then we're going to multiply the bottom by radical 3. Once again, what is radical 3 over radical 3 going to be the same thing as? It's going to be the same thing as 1. because anything divided by itself, with the exception of 0, anything divided by itself is always 1. So by taking radical 2 over radical 3 and multiplying it by 1, we have not changed the value of this expression at all. The only thing we've done is we've written 1 in the format of radical 3 over radical 3. Well, how is that going to be helpful? Well, we'll see after we perform the multiplication. Remember, when you have two fractions being multiplied together, you multiply your numerators together and then your denominators. Well, what is radical 2 times radical 3? Well, remember from our properties, it's going to be radical 2 times 3, which is radical 6. That's our top. Our bottom, what is radical 3 times radical 3? Radical 3 times radical 3 is radical 9. Well, at first sight here, it doesn't look like we're any closer. We still have a radical sign in our denominator. However, we can simplify our denominator simply by solving it. What is the square root of 9? Well, it's 3. So we can actually rewrite this fraction, radical 6 over radical 9, as radical 6. And then in place of radical 9 in the denominator, we're simply going to write 3, because 3 is the square root of 9. This right here is our answer. The square root of 2 over 3 in simplified terms would be radical 6 over 3. We use the same method when we have a variable that's within our fraction that's inside of the square root. So let's go ahead and once again solve this with the same type of method. We have the square root of 5 over y. We're going to break that apart. We're going to take the square root of 5 by itself in the numerator, and then we're going to take the square root of y by itself in the denominator. So we have just simply rewritten the square root of 5 over y equal to radical 5 over radical y. But once again, we want to get this radical sign out of our denominator. And in order to do that, we need to create a square in the denominator. Well, once again, the simplest method to do that is to take whatever you have inside the radical sign and multiply both the top and bottom by that same value. So we're going to multiply the top by radical y, and then we're going to multiply the bottom by radical y. And as we can see, radical y over radical y is the same thing as 1, so we're just multiplying this by 1, which means we are not changing the value at all. Now let's go ahead and perform the multiplication. We have two fractions being multiplied together. You multiply your numerators. So radical 5 times radical y is radical 5y. That's our numerator. And in the bottom, radical y times radical y is radical y squared. We still have a radical in the bottom, but it is in fact a square now, so we can simplify it. The top is going to remain the same, because radical 5y is already in its simplest form. But the square root of y squared is y, because y times y is y squared. So then, the square root of 5 over y in its simplest form is radical 5y over y. And as far as a review, remember that the exponent 1/2 means the square root of something. So x to the 1/2 over y to the 1/2 is the same thing as the square root of x over the square root of y. Next, most of the time it's proper to not have a radical sign in the denominator. So one strategy is to remove the radical sign from the denominator by converting the denominator into a square. Then once it's in the square format, you can then take the square root of it and you will be left with an integer in the denominator, or an answer within your denominator that does not have a radical sign in it. And then lastly, a good point to bring up, at this point in algebra there is no such thing as a square root of a negative number, because remember, a positive number times a positive number will give you a positive. A negative number times a negative number will also give you a positive. So there is no number that you can multiply by itself that will give you a negative answer. In later stages of algebra, and some of the more advanced algebra, they actually have created imaginary numbers, with those imaginary numbers being equal to the square root of negative numbers. But at this point, whenever we're talking about square roots in algebra, there is no such thing as a square root of a negative number. Okay then, that'll finish up session 82.